In this video we'll be covering digital inputs or reading digital information with our Arduino. Essentially when we're doing this we're trying to find out if the particular voltage on a pin is either a high voltage like 5 volts or a low voltage like 0 volts. The most common place we'll be doing this in practice and in the labs will be with switches, trying to work out whether a switch is pressed or a switch is not pressed. So when we connect a switch up to our microcontroller, we need to configure that particular pin as an input. We'll go through that in a moment. When we interface a switch with our microcontroller, we need to connect a pull-up resistor, typically a 10k to 100k pull-up resistor. This is because if this resistor isn't in place and the switch is not pressed, the pin is effectively floating, not being driven by anything, and so it can pick up any radio interference or anything like that. We have input to the microcontroller that can vary with time, go up and down, rather than being a fixed value that we're actually driving. So the way this works is, if the button isn't pressed, the voltage at the pin of the microcontroller will be a high, because that is pulled up via a resistor and is only really connected to VCC through this very large value resistor. If the switch is pressed, the microcontroller receives a low because it's directly connected to ground or 0 volts, and it has this very, very high value resistor, 10k to 100k, connecting it to VCC. So it means that we'll always know with certainty whether the button's being pressed or not pressed. We don't have this in-between state where the pin happens to be floating. So before we actually can read the value of our pins, we need to set them up, and we need to tell our microcontroller that they're going to be digital inputs. This step is called setting the direction of the pins, effectively setting them to be either inputs or outputs. And we use the Pinmode function in the setup function to actually do this for us. Now the way it works is we call the function Pinmode, we specify the particular pin numbers, pin 5, 6, 7 for example, and the direction, whether it's going to be an input or an output. Now normally we give our particular pins some names just to make them easy to refer to, so we do this at the top of our file. For example, int led pin 1 is equal to 10, that's going to be pin 10, and int switch pin is equal to 11, that's going to be pin 11. And we can use these directly in pin mode, so we say pin mode led pin 1 is an output. LEDs outputs are things we drive with our microcontroller, so we need to set them as an output. Conversely, switches are inputs, they're things that we're trying to sense, so we say pin mode switch pin as an input. Now we need one of these lines for every switch or LED, for every input or output that we have connected to a pin in our microcontroller. Once we've set all those things up, in our loop function we can actually read the particular pins, and we have a command for doing that. It's called digital read, and essentially what we say is digital read. We specify the pin number or the name of the pin that we've assigned, and that will return to us whether the pin is a high or a low. It will return to us either a 1 or a 0. So now we'll look at an example where we combine what we know about using digital write with what we know about using digital read. We'll use an LED as an output which we're going to write to and control, and we'll use a switch or a little push button that will read the value of and use that value to control the LED. So let's declare both of those to start off with. So we declare our switch, and we'll say we'll connect that to pin 5, and we'll declare an LED, and we'll say that we'll connect that to pin 6. Next we need to write our setup function where we specify each of these as inputs and outputs. So our switch is an input, and our LED is an output, and then we'll write our code to actually make it do something. So we'll write our loop function, and we'll have an if statement checking if the switch is pressed or not. So we say if 0 is equal to digital read, switch pin. Now if we're checking against 0, what we're saying is if the button's actually pressed, because when the button's pressed we get a 0 voltage or a low voltage at that point. Otherwise, the pull-up resistor that's connected to the switch is pulling it high or up to 5 volts. So what we're going to do, if the switch is pressed, we're going to turn the LED off. The way we do this is we write a 1 to our LED pin. So we set that pin high and turns it off. If we want to turn the LED back on again, we write a 0 to it. There we go. If we upload that now, we'll see it working on the board. So here it is uploaded onto the board. You can see we have our LED connected to pin 6 and our switch connected into pin 5. With the switch not being pressed, we have a 0 being supplied to pin 6, a low voltage, and that turns the LED on. When we press the switch, we have a 1 or 5 volts being supplied to pin 6 now to drive the LED, and that will turn the LED off. We release the switch, once again the LED turns back on again.